Hello, I'm Rick Skarbez, and I just wanted to say thank you all for coming to the engagement session. I hope you are all engaged with today's discussions and with this paper. A couple of quick announcements before we get started. One is that if you have a poster this afternoon, please come 10 minutes early to the fast forward session so that we can get everybody in order and get through the fast forward as quickly as we'd like to. A second is that one of our speakers in the last session has lost a wedding ring. So if you find one, please talk to me or to somebody in a Western Sydney shirt, and let's all work together and make sure that we can send him home happy. And finally, I'd just like to introduce our first speaker for today. This is Seunggon Jeon from Jeeho University, and he's presenting a paper on being more focused and engaged in firefighting training, applying user-centered design to VR system development. Let's welcome our speaker.
Okay. Hello, everyone. My name is Seunggon Jeon. It's a big pleasure, it's a big honor to have a presentation in front of the experts in VR from all over the world. Today, I'm going to talk about how we need to design a VR application, a VR system, and especially I'm going to talk about a firefighter training VR system, and also I'm going to talk about what is needed to be considered in these kinds of training systems. This work is done cooperatively by me, Seunggon Jeon, and Jaeho, Yonggeol, and Kyungsik. Okay, let's go on. So first, let me introduce my work. So VR is a wonderful technique, I know. It is used in various fields such as entertainment or working or trainment, or it can even be used in treatment in the hospital. But VR still has some kinds of problems, and one of the problems is the user experience, the UX. So if you Google in the internet about the problems about VR, many of literature says that user experience is a one big point in VR. So for example, in this survey, many people said that user experience is the biggest obstacle to mass adoption of VR technology. And another example over here, this article says that the biggest barrier to wide adoption of immersive technology is the lack of good user experience design, which is highlighting that the user experience is a very important thing in the VR field. So VR has the opportunity in serious situation training systems, and for example, the fire disaster or the earthquake and plane crashes, due to the vividness and the safetyness of the technology. But because of these kinds of problems that I introduced before, user experience must be considered very heavily to successfully design these kinds of training systems effectively. So our motivation comes out from here. We want to make a fire disaster training system for firefighters, and we want to provide them with good user experience to make them use the system over and over. So before we jump into our research, we needed to figure out that whether the current VR firefighting system provides the firefighters with good user experience. So to do this, we have surveyed 15 firefighters which have the experience in VR training. They said like this: so the current VR training system tends to convey behavioral tips, which is wonderful, which is good, but it does not sufficiently reflect the actual firefighters' needs and the realities in the real field. So our objectives and the contributions of our study is this. So the first thing is that we had employed the human-computer interaction, the HCI methods, to design a VR firefighter system. And we have identified the core elements in the firefighting scenarios and developed those elements into the VR system. And then we have evaluated our system with the respect to presence and three design components, which is reality, meaning, and play. I'll talk what these three are in the related work section. And finally, we have determined the design implications that are expected to help the implementation and provide an effective VR training system. So now I'm going to talk about the core related works we have used. So presence. The first thing that I want to talk in this section is presence. Presence is a very strongly related concept with the user experience in VR. So it is defined in various ways, but SkillMe over here says that in those kinds of definitions, they commonly mention about being there. So for example, if you are playing a VR game, we need to be inside, we need to feel that we are really in the environment. If we want to have a conference, we need to feel that we are really in the conference room. And in our case, we want to plan to make a training system in the fire disaster. We have to feel that we are really in the fire disaster. Obvious, very obvious. And the next thing that I want to talk is about the triadic game design, which is emphasized by Harteveld. He said that when we design a serious game, we need to consider three things, which is reality, meaning, and play. So reality, I'm sure that everybody knows what this means. It is the similarity between the real world and the virtual world. And the meaning, it is the value to provide to the users, in this case, the educational things. And the last one is play. Because this is a game, we have to enjoy the game. And to do that, we have to engage into the VR world. So these four things, the presence and these three things must be considered when we build a serious game with VR. So the next thing that I want to talk is about past VR firefighting systems that was written in the papers. So there are plenty of them, as you can see over here. But some kinds of limitations was happened inside these papers, and we want to make a VR training system by ourselves, but we did not have any guidelines. We did not know what was needed to be implied inside those systems. So we have to make those kinds of guidelines by ourselves because they do not provide them. So this is the limitations of the previous works. So because we needed to design the guidelines by ourselves, we have applied some HCI methods. The HCI method that we have used is called the UCD, the initial of user-centered design. The user-centered design is a design method that is focusing on the user and the user's needs by contacting to the users with feedbacks and updating the system by ourselves. To do this more efficiently, we have done some surveys and interviews, and we have made an affinity diagram. I'll talk about this later. And we also built a scenario too. So rolling up those kinds of related works, we have made the research process like this. In the first stage, we have developed our VR system, and in the second stage, we have evaluated the system. So in the first stage, the first thing we have to do is to investigate the firefighters' needs in the VR training. So to do that, as I said, we use the survey and the interviews. And the next thing is we have to identify the core elements by using the surveys and interviews, the items from there, and make them into the affinity diagram and the scenario. And after that, we have developed a VR firefighting training system by the Unity 3D and 3D modeling, and showed that to the real firefighters and get some feedbacks. And we did this over and over, about 3 times. And after that, we went to the stage 2, the evaluation stage. And in this stage, oh, I forgot this. In this stage, we have compared our system with another system that is currently operated from one of the headquarters that is in Korea, the disaster headquarters. And we have also evaluated the 4 things: the presence, the reality, meaning, and play, and scored them in each of the systems and compared them. This is the end of our research. So I'll talk one by one. First thing, I'm going to talk about the stage 1, the development stage. Yeah. So in the development stage, the first thing that we have done is to investigate the firefighters' needs. So to do that, we have surveyed 15 firefighters who have virtual training experience. And in the survey, we have 2 big questions. One of it is that did they ever felt any anxiety during the past VR fire drill? And the next one is that did they immersed in the VR situation that they had experienced in the past? So the answer was obviously no. As you can see, 54% of the firefighters told us that they did not felt any anxiety, and 62% of the firefighters said that they did not immerse into the VR situation. So then we asked why. We asked why they didn't felt any presence or any anxiety. They said that the situation setting was very bad. it's very bad. And the movement control, it was very awkward. And the anxiety, because it is a VR technology, they know that they are safe. They're not into the real situation. So that makes them to bother to make some anxiety. And so no event happens to make them tense. And so we have asked also, then how can we improve these kinds of things? So they simply answered that then just add some dangerous events such as backdraft or flashover. So these two, the backdraft and the flashover, is some examples of fire explosions that are very dangerous. And another thing that they had said is that they need to move after sitting down like the real firefighters. So because of the smoke, the site is bothered, we cannot see that far. So to have a clear sight, we have to sit in a low position and then move. These are some examples. If you want to see in more detail, please refer to our paper. So after the survey, we have done an interview, but because the interview is not organized, we have organized the items from the interview and the surveys into an affinity diagram. So affinity diagram is a technique that is used to externalize and make sense of and organize large amounts of unstructured data into categories. So in our cases, we have divided our items into 3 big parts. The first one is the situation, and the next one, the user psychology, and the final one is the behavior. I'll talk one by one. So in the situation class, there are items that is about the feature of the fire itself or the feature of the place where the fire is occurring. So for example, burning speed or the smoke spreading speed. These kinds of things are in this class. And the next one is psychology. In this class, there are items that is about the user's sense, what he or she feels, looks, sees, or smells, and what they feels and thinks about those kinds of accepted senses. So for example, the backdraft the explosion makes the firefighters panic, or the smoke is too thick than expected. They said that they cannot even see their own hands. And the last one is the behavior. In this class, there are response methods and some kinds of mistakes that the firefighters can do in the fire situation. For example, as I said, sitting on the floor to get clear sight is some like a response method. It is a behavioral manual. So these kinds of things are in this class. So after making the affinity diagram, we have also made a scenario. The scenario we have made is based on the real fire disaster, which has happened at 2012. It occurred in a singing room, in the singing building, and in the singing building there's many small rooms, and the firefighters said that it's very hard to explore to the singing building because the hallway is very narrow and there are many rooms to explore, and because of that they cannot easily find the people who need to be rescued. So these kinds of things are very difficult to explore, to do. So we have accepted the situation and made it to the virtual environment, as you can see at the right. So you can see some points that are marked with the alphabets here. These are the event points. So when the user arrives at these kinds of points, some kinds of events happen, such like this. So for example, if the user arrived at C, the stair filled with smoke will be saw, and some kind of backdraft will happen at point G. And after that, you can rescue the people who need to be rescued. And after rescuing the person, the scenarios will be end. So I think I can show you a video clip. Oh, no, not this one. Oh, so sorry for the subtitle is in Korean. It's for Korean firefighters. As you can see, in the first point, we can go down to the stairs and see some very thick smokes. Yeah, this. very thick. They cannot even see your hand, their hands, and some kinds of alarms comes up like this. And as you can see, there's a fire over there, and some kinds of sparks happens because of the electrical circuit. And these are the backdrafts, which has happened when you open the door suddenly. So these kinds of things happened, and some rescue methods. Sorry. So the firefighters rescue the people like this. They lift up their legs and pull, and they evacuate after using the pulling system. Yeah, because the person are too heavy. The people are too heavy. Yeah. So after making our system, we have tested it. We have went to the evaluation stage. And in the evaluation stage, we have designed a user study. The goal of the user study is to examine the effectiveness of our VR program for the firefighting training. So to do that, we have recruited 22 participants, and we have done a within subjects user study and compared our system with the system that is operated by one of the headquarters in Korea, which is named Yonggeol Disaster and Safety Headquarters. So the first thing that we have checked here is the presence. As I said, presence is a very strongly related concept with the user experience. To score presence, we have used the IPQ, the I Group Presence Questionnaire. And this is a survey inventory that is divided into four big things, to four big sections. And we have scored each section and compared our system with the control system. And this is the result. So at the first column, you can see the control program, the program that is operated by the headquarters. And at the second column, you can see our program's score. And if you compare them, you can see that our program was better than the control program in every section. And we have also done some t-tests and figured out that, especially in the involvement, the INV section, the p-value was very small, meaning that the involvement was very good in the experiment program, in our program, than the control program. So generally, our system showed greater results in spatial presence and involvement and reality and all. And the next thing we have checked is the aspects of triadic game design. So because there are no survey inventories, we have just directly asked to the participants which one is better. So the green bar is the number of the participants who answered that our program was better, and the red bar is the opposite, the number of the participants who said that the control program was better. As you can see, the green bar is better in every aspect, which is meaning that our system was better. Yeah. So now I'll talk about the discussions of our work. So the first thing that I want to talk here is about the design implications. As I said, we need to have a guideline to make a VR firefighter training system. So you can refer to our the affinity diagram that I introduced at the front, the items. You can apply the items to your own training system to make a good system. And this is the table that the responses, about the responses of the participants, why they felt more presence or reality, meaning and play. So you can refer to this, and if you want to look at it in detail, please refer to our paper. Yeah. The next thing that I want to talk is about the usability of our program to overcome the PTSD symptoms. So researches on VRET, the virtual reality exposure therapy, has been done in many domains, such as the acrophobia or some public announcements. It was successful, and we can apply this exactly into the firefighting domain too. But there are some kinds of challenges to apply this, but still we have the opportunity in overcoming the PTSD symptoms by using our system. Lastly, I'll talk about the limitations of our work. So there are many limitations of our work, but I choose these three to present. The first one is that we did not incorporate all the items identified in the affinity diagram. And the second one is that our target users are firefighters. The system users are firefighters, but the user study was conducted in general public. That is one big problem. And the last one that I'm going to say is that some biosignals was used in the previous studies to check the degree of anxiety, but we did not use those kinds of things. So in the future, we are going to test those things too. Yeah. So concluding my work, we have identified the key elements that need to be considered, and we have applied them to the firefighter VR training system, and we have evaluated in the aspect of presence, reality, meaning, and play, and showed a better result than the current system that is operated, highlighting the importance of a human-centered design approach. Yeah. Thank you for your attention. I think I have some time for your questions.
Yes, thank you very much for your presentation. I see we have a question back here. All part of the job.
Hi, thank you for the presentation. So at the end you said it's more effective, and you're basing that on the three elements that you had in that framework. Oh yeah, could you put up the last slide? Did you measure performance in any way compared to the control system in terms of task completion times? Because the assumption that is being made is that this framework, if you're increasing, I guess the top one is fidelity, then creating a meaningful framework around it, and then playfulness, which would be engagement, is that would result in better performance.
So checking the task time. So I mean, how much time does it consume to do one thing was quite hard in the test, because we need two kinds of very similar VR training systems to do that. Because in the control program, there are some kinds of things to do, like moving. But because moving is done in teleportation at the control program, we do not use the teleportation. So these kinds of things it's very hard to be compared. So sorry for that. Yeah.
So just to clarify, so the control system was also search and rescue task, but it was a different building, different different walking method. Okay, thank you.
Hello, thank you very much. It was a very interesting topic to choose. If you go one slide earlier or forward. I was wondering, so I know the IPQ is a 7-point scale, and if you get like something like 3, I'm not sure if you really can claim that people felt present. I'm not sure, maybe you have a different version of the scale, but on a 7-point scale, getting a 3 out of 7, it does not really seem very strong. What do you think? Or maybe you can explain that.
So that's a very good question, I think. The IPQ, as I said, is divided into 4 different sections, but there are some questions that have the 5 liquid scale, and some questions are in 7 liquid scales. But the 7 liquid scales are very, the amount of them are very, it's not that much. So I think the most of it is in 5 liquid scales. So I think it does not it doesn't matter that much. But yeah, it is a good point.
Any other? One in the back?
When you did the interviews, that was actual firefighters, is that right?
Yeah, that's right.
Yeah, and so then for evaluation you used others, fair enough. But now with those results, is there an intention that, firefighters will use it? Have you been back to them, and do they have an interest to try?
They said after we So as we said that this is done in a UCB process, and we finally confirmed with the firefighters that they said that it was pretty similar. It was good. So, yeah, so I think it is enough for.
But did you invite them to do it? I mean, why don't they want to do it?
Well, so they saw the program. They saw the program. They did not test it by themselves using the head-mounted devices, but they saw the videos and they saw some kinds of things. And in the development stage, because this is rotating, at the first phase they have seen the developed VR system, and then we got some feedbacks from them. And then we developed it again by updating the system, and we did it over and over. So, yeah, at the last stage, they said that it is pretty similar. It is very realistic, and but in the two other stages, they said they did see the program. They did test it. Yeah.
Okay.
I think.
All right. Thank you very much, and let's thank the speaker one more time.